Hey guys, welcome back. Today we start the turbo installation process. Okay, let's talk turbosizing. As cool as this BMW would look with the biggest turbo on the market under the hood, we have to look at all our goals. We want to make sure that we meet the owner's two main requirements. These were 400 wheel horsepower and max boost by 4,000 RPM. Now we can use a much smaller turbo like this GTX 2860 and have max boost pressure in the sub 4,000 RPM range, but we would never reach our horsepower goals because the max horsepower of this turbo is only 475 crank horsepower. Or we can go with the GTX 3584 RS. That's rated 1,000 crank horsepower, but we would have so much lag that the desired boost wouldn't reach until above 4,500 RPM.
So instead of guessing to figure out what turbo to use, Garrett Advancing Motion has developed the Boost Advisor to take all the rocket sciencey stuff out of it. So let's try it out. So we're going to fill out our crank horsepower target. We're going to choose 600 horsepower so we have a little bit of room to grow with this guy. Next up, our engine displacement is a 3.2 liter, and we'll be installing only one turbo at this time. Type of fuel will be E85, air-to-air intercooler, 4 valves per cylinder on this engine. Now, our mid-range RPM is actually our peak torque, what we're looking for. So we choose 4,500 RPM, which is just after where our peak boost should be. And our maximum engine RPM is typically your engine's rev limiter. Next, you set your altitude and your ambient air temperature. Now let's see the recommendations. So for this, it looks like our GTX 3576R Gen 2 will do 400 to 750 crank horsepower on a displacement from 2 liters to 4.5 liters engine capacity. Looks like we know what turbo we're going to run today.
Now let's take a second to talk about response, or as we know it in the turbo world, lag. Turbo lag is the time between the demand for an increase in power, aka the throttle being opened, and the turbocharger providing increased intake pressure, boost. Throttle lag occurs because turbochargers rely on the buildup of exhaust gas pressure to drive the turbine. Turbine performance is greatly affected by the changing of the AR size. Using a smaller AR will increase the exhaust gas velocity into the turbine wheel. However, a small AR also causes the flow to be restrictive at higher engine RPMs. Using a larger AR will lower exhaust gas velocity and increase lag. Basically what we're trying to say is the smaller the AR housing on your turbocharger, the better the spool, but it kills your top end performance. If you go to a bigger housing, you lose spool, but you gain peak horsepower numbers. Up until this point, everything we have covered has been in regard to a single turbo system. Another option is a multi-turbo system, most commonly a twin turbo consisting of 2 small turbos, or a sequential turbo system consisting of 1 larger turbo and 1 smaller turbo. For our build, we'll be going with a single turbo system since we're a little limited on space in the engine bay. Okay, did you catch all that? Enough talking about turbos. Let's get our hands dirty and start installing this thing. Okay, first up, we'll need to remove the pre-existing exhaust system and the manifold from the chassis. Once we've done that, we can install our new manifold and turbo to the engine. We'll need to route coolant and oil to the turbo. We'll start with the coolant. The easiest place to tap in for the coolant is to the throttle body coolant passages. To do this, we'll be using Vibrant Performance lines and AN fittings to adapt to them. Next up, we need an oil pressure feed source. Typically, the easiest place to do this is the oil pressure sending unit, and we'll adapt from there. We will route those lines to the turbo and move on to the oil pan to connect the oil return line. For this, we need to remove the oil pan so that we can drill and weld a fitting. But before you do this, you need to find a good location on your pan to run a line from your turbo. Make sure that the line doesn't interfere with anything like the turbo manifold, and route the line to the highest accessible point of the oil pan. The reason why we access here is because you don't want oil pressure in the return line. This could cause premature failure to the turbo seals. Now that you've marked the spot, we'll have to support the engine with a cradle so we can remove the subframe, and then the oil pan. Once the oil pan is off, you can drill the right size hole for the fitting to be welded on. Vibrant Performance makes aluminum and steel weld-on fittings, depending on what type of oil pan you have. Since ours is aluminum, we'll have to TIG weld the fitting. If you don't have a TIG welder at home, sourcing a reputable fabrication shop is the best option for this part of the process. Now that the oil pan has the appropriate fitting, we can reinstall the pan and start to tailor our return line. Best way to do this is with the turbo mounted onto the manifold, so you can measure twice and cut once. Over the past few minutes, we've taught you how to pick the right turbo, how to mount it, and how to plumb oil and coolant to it. Like this video and subscribe to the channel so that you can join us in the next episode when we start to dive into the fabrication process of this build. If you have any questions along the way, feel free to comment below or contact us via the link in the description.